Good evening, everyone. This is Mike Chi. I'm testing the latest firmware for the RetroTINK-Ultimate. The idea is I just got this PVM20L5, so it's a multi-format monitor. So I want to make sure that the RetroTINK-Ultimate is able to generate the correct sync signals for not only 240p, but 480p, as well as 720p. Unfortunately, the Raspberry Pi doesn't support interlaced video over the GPIO pins, so 1080i is out, but none of us like interlaced anyways. I've been trying to get it working for quite some time. I've tried this HDMI to VGA adapter. Also tried the GERT VGA 666. The problem I think with going to 480p or 720p I've had is mainly related to sync generation. These devices output separate HV sync, whereas the PVM requires composite sync. This Radio Shack HDMI to component video converter did work, but the quality was really bad. So I'm trying really hard to get RGB 720p to work. As a quick recap, the way the RetroTINK-Ultimate generates a sync is through a microprocessor. It extends the horizontal sync during the vertical sync period to generate the correct composite sync signals without changing the phase of the horizontal sync, which leads to AFC-PLL errors. So first, I'm going to test my new firmware by making sure that the 240p mode works. So if you guys take a look at the oscilloscope screen here, the yellow trace is the vertical sync signal. The middle trace in pink is the horizontal sync. Both are being output directly from the Raspberry Pi's GPIO header. And the blue trace here is the horizontal sync signal coming out of the VGA connector. That's what goes out to the screen. Now right now I'm in separate HV mode for driving VGA monitors. So not surprisingly, the blue trace follows the pink trace exactly because there's no modification being made. And as we'd expect, everything's running at 15.73 kilohertz. Now, if I turn on composite sync generation through this switch right here, now the microprocessor takes over generating the composite sync signal. So here, during the vertical sync period, what the microprocessor does is it measures, on average, what the time delay is between two horizontal sync pulses. And when it senses that the vertical sync is active, what it does is it extends the down period of the horizontal sync to generate a composite sync signal. But at the same time, unlike my older XNOR logic gate-based designs, you don't have any phase shift. The falling edge of every horizontal sync, of the composite sync signal, follows the falling edge of the horizontal sync signal exactly, so that the monitor is able to lock onto the sync signal properly and you don't have any screen tearing issues. So this is working really well at 240p. Now I'm going to try to put this in 720p mode and try to verify this again. Okay, I've got my new firmware written, so this should be fast enough to respond to 720p timings. I'm going to flash my board. This code isn't super complicated, but I honestly find that using a microprocessor is pretty handy. A lot of times they're actually cheaper than using discrete logic gates and much more versatile. Let's finish flashing. In addition to generating the composite sync timing, I also use the fractional in divider on this microprocessor to generate the NTSC timing color clock in 240p mode. Let's go back to the scope. So here it's running in 720p mode. Again, you have the vertical sync running at 60 Hertz, and you have the horizontal sync signal running at 45 kilohertz, which is what you would expect for 720p. And indeed, we see a nice composite sync timing that responds fast enough to the shortened pulses in 720p. You can see the longer horizontal sync during the vertical sync period, yet all of the falling edges are still perfectly aligned. Now let's turn on the monitor and see if it works. Okay, now it's wired up to my PVM, but before I turn it on, I want to verify that the sync levels, the composite sync levels, are within spec. I have a 330 ohm attenuation resistor coming from 3.3 volt logic, and that's good. The logic levels have been divided to a signal that's a little bit more than 500 millivolts from peak to peak, so that's a nice compliant composite sync signal for video, and it's not triggering well, but you can see the vertical syncs flash by here and there. Okay, I think we're ready to turn off the screen now. All right, let's see if it works. Right now it's connected to my other Pi playing Street Fighter, but I'm going to go to option A. Okay, looks like RGB 720p mode is up and running. You'll see shortly why I'm not playing games. Why I'm running a Raspbian, but I have to say I'm pretty impressed with the image quality from the 20L5. In 720p mode, this actually almost looks like, well, this basically looks like a VGA CRT. Nice high resolution image, maybe a little bit more blurry. Just imagine how much better life would be if VGA CRTs didn't cheap out and could actually sync to 15 kilohertz. But anyways, it's neither here nor there. So I'm running Raspbian now. Stay tuned. Okay, got my USB stick in. You know, the only thing that's dumb about the 20L5 is in 720p mode, and I suspect 1080i as well, it forces you in the 16:9 letterbox, so you waste the top and the bottom of the screen, even though that may not necessarily be your intention. Whoops. Okay, shortly we'll see what my purpose was. Okay, now I'm going to watch tonight's episode of Star Trek Discovery in 720p RGB mode. Now, yes, I know it's a little bit silly because the video is chroma subsampled, but I think RGB really is probably the best way to connect this rather than using that crappy Radio Shack component adapter I got. So I'm pretty happy now. Thanks for watching. Hope you guys enjoyed this, and stay tuned. Okay, I don't want to film too much of this in case YouTube gets flags me and shuts this video down. But the image is really nice. It's a great way to watch movies. I think watching this using this multi-format PVM makes me want to find one of those HD Trinitron, consumer Trinitrons. I've always hated them, but I'm thinking if I get a good copy, maybe I'll move that to my living room. Okay guys, I actually forgot one important thing. We did the RGB, but what about component video? Now, the component video also supports 720p. It uses sync on Luma, as is the standard, and it's derived from the same sync signal as the RGB. So look at the scope here. Look at the Y channel of the component video. You see a nice sync, and then the video signal here. It's pretty much exactly as you would expect. Okay, and I've got this on RCA jacks going back to the 20L5. Let's take a look at the screen. So this is an RGB mode right now. We've seen this, and I was kind of curious, so what is the difference between RGB and component? So I'm going to switch over to component. Overall, it looks pretty similar. I don't know if you can see in the video, but if you look really closely, compared to RGB, the text and everything is just a little bit blurrier. Not significantly so, but RGB is still, I would say, just a notch better. Of course, since it's 720p, there is no composite or S-video. Okay, I'll go back to my movie now.
Previously on Star Trek Discovery.
So thanks again for watching. Hope you guys didn't get nerded out, and hope you guys at least thought this was somewhat interesting. For everyone who's ordered a RetroTINK-Ultimate right now, thank you so much for your support. It's been a pretty busy weekend trying to fill the initial orders. I really wanted to get everything built today, but I think I'll need until Tuesday. I'm still missing a few parts that I'm short of. I've overnighted them, so they'll ship Monday, be here on Tuesday, and I should be able to finish them shortly thereafter. So thanks again for your patience, and thank you everyone for your support.